We're going to work on simplifying complex rational expressions. So essentially we're going to take a rational expression like this one. So let's say we've got a plus 5 over a squared all over a minus 2 over 3a. And we're going to simplify it, which means that we're going to take this fraction of fractions right now. This is our big division bar, fraction on top, fraction on the bottom, and create it into a simple fraction with no denominators here or here. So as we work through this, what we're going to do is use the LCD method. There are more methods than just this one, but we're going to use the LCD method, which means that we're going to identify the LCD between the denominators inside the rational expressions. So this is a denominator, a squared. 3a is also a denominator. So the LCD for both of these then would be, let's see, we need a 3 for the coefficient, and we have an a here but an a squared here, so our LCD is 3a squared. We're going to multiply this fraction by a 3a in the numerator and a 3a in the denominator. Essentially we're multiplying by something over itself, which is 1, but really we're just multiplying top and bottom by the same value to keep our fraction balanced or equivalent. So as I multiply this through, think of the 3a's being in a numerator when I look at this problem up on top. If it's helpful, you can write this as 3a over 1 so you can keep track, because you're going to be canceling diagonally. Same story here. 3a is also in the numerator for the bottom, so you're going to be canceling the 3a and the 3a. Oh, and I said it was 3a squared, didn't I? So I better change that to a 3a squared. Now I'm going to go through and cancel these. So I can cancel the a squared with the a squared. In my numerator, I have the entire a plus 5, still multiplied by a 3, so I use parentheses, but there's no more denominator up there. On the bottom, I can cancel the 3 and an a, which leaves me with 1a left. So I've got the a minus 2, but still this entire polynomial here is multiplied by the leftover a. And then I keep simplifying. I can distribute the 3, and I get 3a plus 15 in my numerator. In my denominator, I distribute the a, and I have a squared minus 2a. So this is what we call a simple rational expression. It's simple because we have a polynomial over a polynomial, no fractions inside. Let's do a second example. So we'll call that 1. So for number 2, let's work this one. We have 5 over 4x cubed minus 3 over 8x, all divided by 3 over 2x plus 3 over 4x cubed. Okay, again, a complex rational expression because I have fractions inside the fraction. Using the LCD method, we need to find the LCD of all of the denominators. So I run through these fractions. So there they are. There are 4 of them. So I take a look at my 4 denominators, and I decide what coefficient I need for the LCD and what power on the variable. Let's see, 2, 4, and 8. I need a common multiple of all of those. 2, 4, and 8 all divide into 8. So my coefficient is the 8. For my x's, I look for the highest powers because I need everything covered. So it looks like x cubed. My LCD is an x cubed. So what I need to do is to multiply the entire numerator by the LCD, which is 8x cubed, and I multiply the entire denominator by that same 8x cubed. Well, I like to think of it this way. I'm going to take my numerator and I'm going to take each piece. So the 5 over 4x cubed, it needs to be multiplied by an 8x cubed, so times 8x cubed. Then I have the minus 3 over 8x, which needs to be multiplied by the 8x cubed. In my denominator, I am distributing, but I'm thinking of this as each term, each fraction needs to be multiplied by the 8x cubed. So in the denominator, I have 3 over 2x multiplied by the 8x cubed. So I'm running my LCD through all of these fractions, plus the last fraction, 3 over 4x cubed, also needs to be multiplied by the 8x cubed. So I've got 1, 2, 3, 4 of my fractions, and each of those fractions is now multiplied by my LCD of 8x cubed. Now if I've done this right, all of my denominators will cancel. So I should not need as much room in my answer down here. As I cancel, the 4 goes into 8, and it leaves me with a 2. The x cubes cancel, and I have 5 times 2, which is 10. Okay, next, the 8's cancel. The x cancels with one of the x's, which leaves me with 2 of them. So I have minus 3x squared. Minus 3x squared. In my denominator, so far so good, 2 goes into 8, and it leaves me with a 4. X cancels with one of these x's, and I've got 2 left over. So I have a 3 and a 4, so that would be 12x squared. And finally, the 4 goes into 8 twice, and the x cubes cancel. I've got 3 times 2, which is 6, plus 6. That's my answer. There's nothing else I can do. I can't factor out anything that will allow me to cancel. So I'm going to leave it just in this form. Let's do one more. So for the final one, we are going to look at, let's do for number 3, 5 plus 3 over x squared y, all divided by 3 plus x, which is a numerator, over x cubed y. So as I take a look at what I have here, I really have 3 fractions. This fraction is an exciting one. It's just 5 over 1. So the denominators that I'm going to use to build my LCD are these two. I've got the x squared y and the x cubed y. My LCD then needs to have the largest power on each of those variables. So let's see, x squared needs an x cubed instead. So x cubed. Both of them have just a single y, so a single y will work for our LCD. So my LCD is x cubed y. I'm going to run that LCD through and multiply it by each of the terms of my complex rational expression. So I take the 5 and I multiply it by an x cubed y. Plus sign is next. I take the 3 over x squared y. I multiply it by my LCD, x cubed y. In my denominator, I have this last fraction, which is 3 plus x over x cubed y, and I multiply that by x cubed y. So you can see that I have the original 5 times the LCD, the next fraction times the LCD, and my denominator's fraction times the LCD. So now I run through and I simplify. I don't have any denominator to cancel that came with a 5. So I'm just going to copy that one, 5x cubed y. Now I can cancel this one. The y's cancel completely. I have 2 x's, and that leaves me with a single x, plus the 3, so I get plus 3x, or x to the first. In my denominator, the x cubed y completely cancels. So I completely cancel that, and I'm left with 3 plus x. I could factor an x out of my numerator, but it's not going to cancel with anything in my denominator, so I will leave this as my answer.